This lecture, we'll talk about operating systems a little bit, what an operating system is. Now, they're not always present in IoT devices, and in fact, with the platforms we'll be working with an Arduino and a Raspberry Pi. With an Arduino, you do not have an operating system. It's really too slow to support that. But Raspberry Pi, you do, typically. So we'll talk about the role of an operating system in an embedded system and an IoT device. You may or may not need it. So an operating system, it's an extra layer in between the program, your application code, and the actual hardware. So generally, say we were working on an Arduino, right? There's a user at the top who's using some application, right? And this application, by application we mean the actual program, right? So you've compiled the program, and that application, that's the application code. Now, if it were an Arduino, that application code would connect directly to the hardware. So it would go straight from the application to the hardware, no operating system at all. And the application directly controls the hardware, sets signals high and low, and so on. But in, say, a Raspberry Pi or a more complicated IoT device, you would have something like what you see here, where the user talks to the application code actually may not directly connect to the hardware, it communicates with the operating system. So it makes calls from the operating system and requesting hardware service, and then the operating system manages the hardware most directly. So that's where an operating system fits in the picture, that the code that you write and compile, the application code, that interfaces with the operating system, and the operating system deals with the details of interacting with the hardware. So it manages other programs. So one thing about an operating system is that it allows you to have not only one application, but many applications. So you can run lots of different applications at one time, and the operating system itself manages the hardware. So it gives them turns, lets them take turns, and stuff like that. And you see this in standard operating systems like Windows or in iOS or something like that. You run, typically on a laptop, desktop, you run many programs at one time. And the operating system allows you to do that, right? Without an operating system, you can only run one program at a time. So you can execute a lot of programs together, and when you're executing together, remember, they're not actually executing together, they just seem like it. So it's really alternating, but very fast, faster than a human would really notice. So it looks like they're all running at the same time. Nice user interface. So often, now how nice a user interface really depends on the operating system. If you look at a desktop or laptop, Windows, iOS, Linux, something like that, they will have a very nice user interface, a graphic user interface, GUI. You can double click on something, double click on a file, it'll open it up, that sort of thing. That's a full-on operating system. The operating systems that you find in an IoT device, they're much smaller and stripped back. So they're not likely to have any graphical user interface or anything like that, but they will have a user interface, a command line. So if you ever use a Windows command line prompt, or iOS, you use a terminal window, Linux, you use a terminal window, something like that. I call that a nice user interface. It's text-based, but it's nicer than not having it. So there's a user interface that's provided of some kind. And it needs processing power. So one thing about operating systems is that operating system itself is a big program, right? It's a big program that's running in addition to the actual programs that you want to run on your IoT device. So it's going to consume clock cycles, right? There are some clock cycles that are spent doing operating system tasks, right? Some memory that's spent storing the operating system data, things like this. So the operating system itself takes up resources. So you have to make a decision as to whether you need one or not, because it's going to cost you resources, which means cost you money. It slows down the system because the operating system, while the processor is working on the operating system, executing the operating system code, it can't be executing your actual application. So it slows things down, and so as a result, when you use an operating system, you generally need a faster processor. That's why if you look at an Arduino, which is running at maybe 8 megahertz, something like that, you usually don't support an operating system with that. But if you run a Raspberry Pi and you've got like 1 gigahertz, then it's okay to support an operating system because it has enough clock cycles that you can do that. A little example of an operating system that I had a student group do something like this, do a project like this several years ago, where they wanted to have a web-controlled car with a camera. So it's an RC car controlled through the web. So you can go to a laptop, desktop, whatever, anything that has a Wi-Fi, could go to a phone, open up a browser, and connect to the car. And the car has on it a camera and its own web server. right? So you can connect to its web server and control the car through its own web server. So it has an interface that looks roughly like what you're seeing down here. On the one side, there's a picture, the image of what the car sees. So that's actually coming from the car's camera. So like I said, the car on it had a camera that was connected to a web server. So the view from that camera would be streamed through Wi-Fi over to whatever your browser device is, right? Then it would have buttons forward, back, left, right to control the car. So you click forward, it would move the car forward. Click back, it would move it back, and so on. So you can send commands to drive the car through Wi-Fi to its web server, to the car's web server, and that would directly control the steering and the motors and all that. So in a system like this, it's useful to have an operating system because there are so many things going on at one time. So the car is controlled over the internet, Wi-Fi generally. The car has its own web server, which has an actual a URL address. And the web interface allows you to control the car and see the images and so on. Also, it has an auto brake feature to avoid collisions. So it'll stop automatically regardless of what your controls are. If it senses something in front of it, it'll stop. But the idea is that it generally has a lot of tasks to do, a lot of things to do at one time. And in that type of situation, an operating system can be very useful. Thank you.